So yesterday, we were talking about radioactive decay, okay, and there were three types of radioactive decay, lah, okay, that we talked about, which is the alpha decay, the beta decay, and the gamma decay, okay, and we learned that different types of decay will produce different types of output. Okay, so the alpha decay is it produces an alpha particle, which is known as the helium atom. Okay, so helium 42 lah. Hold on. Okay, and then the beta decay produces a beta particle, which is known as an electron. Okay, and we learned that the electron, the the numbers that we write for electron are a little bit different than normal. Sorry. Okay, so it'd be 0 and -1. Okay, so this is the beta particle. Okay, so why do they call these beta particles? Why can't they just call it the helium particle or the electron particle? Okay, I think that one you will have to ask the scientists lah. Okay, suka hati diorang lah, dia mau kasih nama apa bahkan. Okay, so we just have to accept that the beta particle is also known as the electron. The alpha particle is also known as helium. Okay, and lastly, gamma decay, okay, produces only a ray, okay, a ray of energy, which is called gamma ray. Okay, and gamma ray is something that we learned in Form 4 when we were doing electromagnetic waves. Okay, but so part of the process of decaying, okay, decaying bila kita mereput bahkan, okay, for example, kalau kulit kita mereput or something kan, parts of our skin will drop off. Okay, sebahagian daripada badan kita bahkan akan, akan mereput dan akan hilang. So kita akan merasa kekurangan. We will feel that there is less and less of us. Okay, so the same thing like uranium, when uranium decays, okay, so let's say for example, this is a block of uranium lah. Okay, so when uranium decays, okay, when it decays, sebahagiannya akan keluar, okay, and 42 helium lah. So an alpha decay will make it to become, will release an alpha particle, okay, and after that it changes. Okay, it changes to become, in this example you see is thorium lah. Okay, thorium 234, TH234. Okay, in the example you see here. And then it continues to decay. Tapi the original element, okay, yang ori adalah uranium 238. Okay, and the process of the decaying doesn't happen instantaneously. Dia bukan zup, habis sudah, tiada. Okay, sometimes it takes a very long time for something to decay. It is a process that takes sometimes very long and sometimes very short. Okay, and if you remember in yesterday our discussion, I said that radioactivity is something that happens spontaneously. Okay, secara rawak, dan you cannot guess when it's going to happen. Okay, and you cannot guess how it's going to happen. Okay, so it's very spontaneous. But over a period of time, okay, we can actually begin to see that there is a certain pattern lah. Okay, and this pattern, scientists have called this pattern a half-life. Okay, so we have called this pattern a half-life. So what is a half-life? Okay, so when a sample of radioactive material decays, okay, the number of parent nuclei, okay, which has not decayed, decreases with time, while the number of daughter nuclei increases. Okay, this is an important thing we need to understand. When something is decaying, yang asalnya akan berkurang, okay, yang belum terurai lah, okay, akan berkurang, tetapi yang the daughter lah, okay, yang terhasil lah akan makin banyak, makin bertambah. Okay, and so the half-life, otherwise known as T-half, okay, so this is the symbol for half-life, is the time taken for a sample of radioactive nuclei to decay untuk mereput to half its initial number or mass or activity. Okay, and this is the meaning of half-life. How long it takes for the original to become half. Okay, how long it takes for the original to become half. For the half to become Not another half, come on. So let's say the original is 1. Half of it is half lah, bahkan. What is the next one after this? Jangan juga kamu cakap kosong, saya tampar muka kamu ini. Come on, half of it can't be 0. Okay, it is 1 over 4. Half of half is 1 over 4. Half of 1 over 4 is 1 over 8. Half of 1 over 8 is 1 over 16. Okay. Now, in this way, it tells us that there is actually tiada penghujung, there is no end to this decaying. Okay, there is no way that a radioactive sample can decay and it will totally disappear from the surface of the Earth. No. Okay, it will always be there, but it will get much less and less and less and less and less. It will just become half and half and half. So if the time, takes from 1 to half, is called a half-life, T half, it is the same amount of time for the half yang sedia ada untuk menjadi kurang sebanyak separuh, which is 1/4. Okay, so yang tinggal adalah satu suku. Okay, so it is the same amount of time. Okay, it's hard for us to believe this now, but actually it's the same amount of time. We always think that dia bukan satu janjang arithmetic. It is not an arithmetic progression. It is actually a geometric progression. Okay, the time that it's taking is the same, but it always reduces sebanyak half. And because it is reducing by half, it is never going to completely disappear altogether. Okay, it's never going to completely disappear altogether. Okay, let me give you another example. Let's say originally I got 100 grams. Okay, and then half of 100 grams is 50. Setengah kan? Setengah daripada 100 gram adalah 50. Setengah daripada 50 is 25. Half of 25 is 12.5. Half of 12.5 is 6.25. So dia bukan 100 kurang sampai 50 dan kurang sampai kosong. No such thing. Dia adalah half daripada yang sebelumnya. Half daripada yang sebelumnya. A geometric progression. And so if the time that is taken for the 100 grams of uranium, example, 100 grams of uranium, let's say it takes 2 years to decay from 100 grams to become 50 grams, it will also take 2 years for 50 grams to become 25 grams. And it will also take 2 years for 25 grams to become 12.5 grams. And it will also take 2 years and so on and so forth. It will always take 2 years or a half-life. Okay, it will always take a half-life for it to reduce by half. That's why it's called half-life. Okay, sebab dia punya life jadi separuh. Okay, daripada yang sebelumnya. Bukan daripada yang asal. So this is a very common thing that I always see a lot of people making mistake. They think 150, then the next one is 0. It is not an arithmetic progression. It is a geometric progression. Okay, and this really, we cannot, honestly, some of us, we cannot brain this, because we think that, okay, if the amount of time, 2 years, change from 100 to 50 gram is 2 years, means from 50 gram to 0 gram is also 2 years. And unfortunately, that's not the case. Okay, unfortunately, modern physics explains this. Classical physics cannot explain why. Kenapa? Why is it 50 to 25 is also 2 years? It doesn't make sense to us, to people who are studying classical physics. Okay, and this is why this topic comes under modern physics, because in modern physics, when you go into higher levels, this is what you will study. Why does it take the same amount of time for it to become kurang sebanyak 25 saja pun? Ini kurang sebanyak 12.5. Okay, but what we are actually missing is that it is reducing by half. Okay, and that is why it is spontaneous and unpredictable. We can only predict after we see, after a long time. Okay, so after one half-life, the number of nuclei that is not decayed will be half of its original value. Okay, when an unstable radioactive nucleus decays, the new nucleus that is formed may also be unstable. And so the new nucleus will experience a series of continuous decay until a stable nucleus is formed. Okay? So this decay can be alpha decay, can be beta decay, can be gamma decay lah. Okay, we don't really know, but all we know is the original uranium, okay, how much uranium you have, by the time it becomes half, it will be a half-life. Okay, so the half-life of a radioactive nuclide, for example, barium has a half-life of 12 seconds. That means every 12 seconds, if you start with 10 grams of barium, 12 seconds later, you will only have 5 grams. Okay, after that, you will have 2.5 grams. And another 12 seconds, you will have uh, uh, no, sorry, 1.25 grams. And another one after that will be so on and so forth and so on and so forth. Every 12 seconds, it will become half. Okay, tapi, okay, then, and this is something that we also need to understand lah. Dia bukan, okay, dia bukan 10 grams. Okay, and then 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, Shazam, terus jadi 5. Tidak, it's not like that. Okay, dia actually is just decay, then after 12 seconds, dia sudah jadi 5. Okay, dia bukan boom jadi 5 macam tu. It doesn't, we always tend to think that half-life, that means antara 1 hingga 12 saat ini bahkan tiada apa-apa yang berlaku tau. No, that's not the case. Actually, the moment you put it out, it starts to decay. Okay, dia akan mula mengurai sudah. Dia akan mula mereput. Okay, but we find that, 12 seconds later, dia sudah mereput so fast that it has become 5. Okay, it has become half of its original value. Okay, so a few things that we have to kind of throw away from our concept lah. Dia bukan every half-life kan terus boom macam itu, but it doesn't like magically become half lah. It actually over a long period of time. Okay, and this is another example. Carbon-14 has a half-life of 5,730 years. It takes 5,730 years for 10 grams of carbon-14, okay, to become 5 grams. Okay, don't tell me 5,730 years, boom, that happened, terus jadi 5 gram. Tidak. Okay, over 5,730 years, it will decay slowly until 5,730 years later, it has become 5 grams. Okay, so the process of decay is always continuing. Dia continuous process lah. Dia bukan sekali boom, tidak macam tu. Okay, but actually it is a continuous process. It happens over a period of time, whether it is 12 seconds or 5,730 years. Okay, but the constant thing about this lah, after years and years of research, the constant thing about this is that there is a pattern that scientists can see. Okay, is that after a certain amount of time, the amount has become half. The amount has become half. Okay, dia bukan 150 0, no, 150, 25, 12.5, 6.25, and so on and so forth. Okay, so in a radioactive decay series, radioactive substances often decay several times, a series of steps. Okay, emitting radiation and producing a new substance at each step. So a parent substance produces a daughter and granddaughter and granddaughter and so on and so forth in what we call the decay series. Okay, this process continues as a radioactive decay series until a stable nuclide is reached. So they can decay until it reaches stability. Okay, so each decay will either emit an alpha or a beta, and sometimes dia akan bergabung dengan gamma. And I said this yesterday lah. Sometimes the alpha and gamma akan bergabung, or beta and gamma akan bergabung, but the alpha and beta cannot happen at the same time. Okay, and this is in your textbook lah. Actually, this is everything from your textbook. So if you see this, this is a uranium-238. This is a very standard uranium-238 decay series. Okay, so the first decay happens at 5,000 million years later. Then only got one alpha decay, okay, to produce 234 thorium, or thorium-234. Okay, 24.1 days later, okay, there will be a beta decay that produces a palladium-234. Okay, 1.8 minutes later, it will be another beta decay to go back to uranium-234. And it will go on and on and on and on until it finally reaches a stable nuclide. Okay, a stable nuclide, which in this case is plumbum 206 lah. Now, at this stage of your physics, chemistry, and your science career, you are not expected to know apa yang tidak stabil dan apa yang stabil lah. You don't really have to know which is stable, which is unstable. Okay, but we know that all radioactive substances are unstable. Okay, and benda-benda yang kamu jumpa di dalam jadual berkala, all the ones, well, most of it lah, okay, in your periodic table are all stable elements. Okay, means dia tidak akan terurai sendiri lah. Okay, remember, decay happens in an unstable substance. Okay, dia tidak stabil. So bila dia tidak stabil, dia kena melepaskan sesuatu untuk menjadikannya lebih stabil. But once it has reached stability, okay, dia dia tidak akan terurai sudahlah. Okay, and this process takes millions of years. Look at this, 4.5 to the 10 to the power of 9. That's 4,500 million years. Okay, for uranium just to have the first decay. Okay, so uranium-238 is a radioactive element with a very long half-life, which is about 5,000 million years. Okay, the element is trapped, okay, during the formation of rocks. Okay, and the trapped uranium-238 will decay, and eventually it will form lead-206. So one of the uses for this half-life research, okay, in nuclear physics, is to determine how old certain rocks are. Okay, so if you're into archaeology, if you're into geology, you want to know how long the dinosaurs were and everything, this is part of the technology that determines that. Okay, so the process takes a long time because the decay rate is low. Okay, now we determine the ratio of the lead to the uranium-238. Because remember, in this one, we know that the unstable nucleus is uranium-238. Okay, after a long while, okay, it finally becomes stable at 206. And we can determine how long this whole thing is lah. Okay, you can calculate 4.5 times 10 to the power 9 years plus 24.1 days plus 1.8 minutes plus everything. Make sure you change it into the correct unit, and you will know how long it takes for uranium-238 to become 206 plumbum, okay, which is a stable one. And from there, okay, from there, we will know how old this particular rock is lah. Because sometimes uranium kan dia akan ditutup oleh batu. Okay, so bila kita korek satu batu keluar kan, we want to know how old is this rock. And then we see, di dalamnya ada satu uranium. And some of it is plumbum also, or lead-206. Okay, the higher the ratio, that means the more uranium than lead, more lead than uranium. More lead than uranium. Kan, sebab as it decays, uranium akan berkurangan dan plumbum akan, meningkat lah. Kan? So if there is more lead than uranium, okay, that means the rock is very old. If the uranium is banyak tapi the lead is sikit, means the rock is pretty new lah. Okay, it's pretty new. So the geological method of measurement can also estimate the age of our Earth. Okay, our Earth is about 5 billion years old. About, I think so. Okay, and it's not just a random number that orang fikirkan macam tu tau. Okay, it is done by years and years of research. Okay, and especially by using nuclear physics. Okay, to estimate the age of certain things lah. That's why people can say, this tree is so and so years old, this rock is so and so years old. Okay, bila orang korek tulang daripada this one, okay, let's say ada orang meninggal lah, okay, and then you korek the tulang, right? Okay, people can, dia bukan tengok saja itu tulang, saya rasa ini baru 50 tahun yang lepas lah. Tidak, no. There is a certain technology, there are machines that can tell you how old a certain sample is. Okay, and all this is done by using nuclear physics, technology from nuclear physics. So nuclear physics is not just all about bombs. Okay, we estimate a lot of ages, okay, by using the technology of nuclear physics. Dinosaur bones, rocks, okay, the how old Gunung Kinabalu actually is. Okay, all this can be determined, okay, by using radioactive decay and the concept of half-life. Okay, especially when we know how long the half-life of a certain element is. Okay, so radioactive materials are usually stored in a thick sealed container made of lead, okay, for safety purposes. Now remember, there are three types of decay. There are alpha decay, beta decay, and gamma decay. Alpha decay can be stopped by paper. Beta decay can be stopped only by aluminium. Okay, so paper tak boleh jadi. But only gamma decay, only gamma rays can be stopped by lead, aluminium. Sorry, only by lead. Okay, so lead can also stop beta lah, obviously lah kan. Sebab kalau lead can stop gamma, it can also stop beta. Okay, and alpha can be stopped by all three. Okay, aluminium and lead. Okay, can stop all three. So if you're going to build a box to keep a radioactive substance, obviously you're going to keep it in a lead box, lah, right? You're not going to keep it an aluminum box, because what if gamma rays come out of it? Then, it's not going to be good for you, lah. Okay, so here's another one. Radioisotopes. Okay, this is, I'm just going to say this in passing. You don't really have to know this. But radioisotopes, I hope that you know what are isotopes. You study this in chemistry, right? So isotopes are, same same proton number but different nucleon number. Same element, but it's just different nucleon number, different number of neutrons. So radioisotopes are the same isotopes, but the nucleus is unstable. Okay, there are some stable isotopes, okay, and there are some radioisotopes. So radioisotopes are isotopes that have unstable nuclei. Okay, go and refresh back in your chemistry. What are isotopes? Okay, you studied this in Form 4. Okay, let's do a little bit of calculation questions. This is somewhere at the back of your module. So, radioactive atoms in a substance decay to become stable atoms. It is found that after 288 seconds, 6.25 have not decayed. Okay, so what is the half-life of the substance? What is the T half? Okay, so when you see this one, 6.25%, you always start with 100%. Okay, because percentage maximum is 100%. So you start with 100%. Half of 100 is 50. Half of 50 is 12.5. Half of 12.5 is, 25. Half of 25 is 12.5. Half of 12.5 is 6.25. So you reach this one. That means out of the 100% of atoms that were originally there, after a certain number of half-lives, there were only 6.25 left. Yang baki adalah 6.25. Dan kita dapati adalah 4 half-lives. 1 half-life, 2, 3, and 4 half-lives. Equals to 288 seconds. Okay, so obviously, if 4 half-lives is 288 seconds, 1 half-life will be 288 divided by 4, which is about 72 seconds. Okay, again, just to remind you that this 150, it is not selepas 72 saat, bahkan 71 seconds of silence. And then at the 72nd second, boom, terus 50% yang tinggal. No, it's not that. It is starting from the first second, dia decay slowly. Then 72 seconds later, kita tinggal 50%. Okay. And 72 seconds later, masih ada tau. Bukan dia terus pergi kosong. Okay, again, decaying never stops. Okay, it never becomes zero. It just becomes less by half. Second question. Half-life of iodine 131 is 8 days. Okay, a radioactive sample contains 64 grams. So determine the mass of iodine that has decayed and has not decayed after 24 days. So let's talk about this. 24 days means how many half-lives are there? We're talking about 3 half-life. So if the beginning is 64, 3 half-lives later, 64 becomes 32, 32 becomes 16, 16 becomes 8. And this 8 is has not decayed. Okay, so kalau yang belum mereput adalah 8, yang sudah mereput adalah 64 minus 8. So itu sudah mereput. Okay, so the amount of iodine that has decayed is 56 grams. And the amount of iodine that is left, okay, this is what this number means. Okay, the number that is left is the number that has not decayed after a certain number of half-lives. Okay, so kalau mau cakap dari segi calculation, maka ini susah. It is not that difficult lah. You just have to know what a half-life is and that it always reduces by half. Okay, bukan dia pergi zero. The moment kalau kau tulis zero, bahkan you need to tell yourself tiada perebutan sampai kosong, tiada. Dia tidak akan gaib dari dunia ini. Okay, it will always be there, but it will get less and less and less and less and less. Third question. Sample of lead 211, okay, lead is plumbum, 211 of mass 96 grams has a half-life of 36.1 minutes. So, question is, what fraction of the sample has not decayed, okay, after 108.3 minutes? Okay, let's set it first. How many half-lives are there? If one half-life is 36.1 minutes, 108.3 minutes will be 3 half-lives. Okay, 3 half-lives. So once you have the number of 3 half-lives, then you know that you need 3 arrows. Kan? So you start with 96 grams, and then you have the 3 arrows, and then you divide everything by half. 96 bahagi 2, 48. 48 divide by 2, 24. 24 divide by 2, 12. But the question is, what fraction has not decayed? Now, kalau soalan minta fraction, you have to give a fraction lah. So it will be, so it will be, so the fraction now will be 12 out of 96, which is 1/8, yang belum decay. Okay, and what is the mass of the decayed products after this period of time? Yang sudah decay adalah 96 minus 12, sebab 12 adalah yang baki. Okay, so that's why you get 84 grams, which is this answer. So this one is a bit wrong, because question is asking for fraction. So 1/8 yang belum decay. 7 out of 8 has already decayed after 3 half-lives. Okay, so different materials have different half-lives, okay, but the concept of half-life is still the same. It is the life for half of it, okay, to be gone. Okay, and that is the only thing that you know, in nuclear physics, that is the only thing that is constant. Okay, we don't know, okay, let's say for example, we know that 96 to become 48 grams, okay, it takes 36.1 minutes. Okay, but we don't know, you know, dalam 36.1 minit ini kan, adakah dalam minit pertama itu sikit keluar, dalam minit kedua itu sikit keluar, atau minit pertama sampai minit kelima kan tiada apa-apa yang berlaku. Tiba-tiba in the 6 minute kan, suddenly 50 grams tiba-tiba mereput sendiri. Okay, yeah, tiba-tiba 50 grams mereput sendiri. Okay, and then after that no activity again, and then after that finally at the 35th minute baru yang, you know, so we don't know, we don't have that kind of information, because again, radioactive decay is a spontaneous process. The only thing that we can predict about it is how long it takes for it to become half. Itu saja yang kita dapat tentukan. Okay, tapi secara detail bila masa dia berkurangan ini, you know, in the 36.1 minutes kan, 1 minute itu how many yang decay kan, we cannot determine that, and it is not, we cannot determine it that way. Okay, kita tidak boleh cakap, oh okay, 96 to 48 means, okay, 48 grams yang hilang dalam masa 36.1 minit. Means 1 gram itu adalah berapa minit. Okay, tak boleh. We cannot do this for radioactivity. Okay, because this kind of mathematics doesn't work. It is unpredictable, it is random, and it is spontaneous. The only thing that is for sure is the half-life. Okay, so we cannot use this kind of logic. Tak boleh, tak boleh. Okay, cannot. Kalau half-life-nya ada 36.1 minit, that means 1 gram itu berapa minit yang tiada, no such thing. Okay, sometimes they decay a lot, sometimes they decay a little bit. Okay, but we know that in the 36.1 minutes, half of it will be gone. Okay, that's as much as we know. All right. Okay, one more question. The activity of a radioactive sample is reduced to 1/6. This is wrong. This is 1/16, right? Okay, 1/16. Okay, of its initial value after 156 minutes. So notice the few questions that they ask. Sometimes dia bagi in percent. Kalau in percent, you start with 100%. Sometimes they will give it to you in grams. It means they already give you the mass. So you start with the mass that is given. But sometimes they will give to you in a fraction, 1/16. If percentage is 100%, if the mass, we take the mass, if it is the fraction, we always start with 1. Okay, because fraction. Start with 1, half is half. Half of half is 1/4. Half of 1/4 is 1/8. Half of 1/8 is 1/16. Itu yang kita mau. And how many half-life it is? 1, 2, 3, 4 half-lives. So 4 half-lives is 156 minutes. Therefore, every half-life is 39 minutes. Okay, 39 minutes, 39 minutes, 39 minutes, 39 minutes. Okay, so these are some sample, pretty easy actually, and it's just logic lah. Okay, as long as you know how the meaning of the word half-life. Okay, maksud half-life itu, okay, dia punya concept lah is very important. Okay, once you understand it, it's quite easy to do these calculation questions. Cuma dia punya, dia punya types of questions can be different lah. If they give you percent, start with 100%. If they give you fraction, start with 1. Then divide by half. Sorry, 1 divide by 2, okay? And if they give you the mass, use the mass given, okay? Totally no problem. Okay, now for your work this weekend, okay, I want you to do this activity in your textbook lah. Okay, I want everyone, okay, to draw a decay curve. Okay, so let me explain to you how to do this. So the activity is actually in your textbook lah. Page, I don't know what this page is, but it is activity 6.3. But I want to change this a little bit lah. Okay, so the aim is the same. The aim is to draw a decay curve. Okay, now the apparatus is going to be crazy to find 60 dice lah. Nobody has 60 dice at home. So what I want you to do is this. You have two choices lah. Either you get this is very, very weird lah. 60 coins. That is the same kind of coins. Means either 10 cent or all 20 cent or all 50 cent. If you can lah, if you can. Okay. If you don't have 60 coins, actually 61 cent coins also can. I have 1 cent coins. But well, that's me lah. Okay, you either do 60 coins, or what you can do is you can take a manila card, not paper. I don't want paper. Manila card, okay, atau card yang tebal bahkan. Okay, and so what you do with the card is, so let's say this is your card lah. Okay, this is your card. What you do is you cut about maybe a 50 cent size kind of coin. Okay, then yeah, kind of like this size lah. Okay, kind of like this size. And then kau tulis di sebelah kepala dan sebelah ekor, head or tail lah. Okay, ini kepala, ini ekor, or whichever one you want lah. Okay, and you make 60 pieces of this. Okay, 60 pieces of this. But cannot be paper, because if paper then it will fly away, don't want. We want something a little bit more stable like manila card. Okay, but 60 pieces of the same size like this, okay, small size enough, as long as it can represent the coin, one head and one tail. Okay, if you have 60 coins at home, make sure it's 60 of the same coin lah. Kalau 50 sen, semua 50 sen. Kalau 10 sen, semua 10 sen. Tidak boleh campur-campur. It doesn't work that way. Okay, it has to be the exact same kind of coin or the exact same kind of Manila card. Okay, and so what you do is you put everything into a plastic bag. Okay, so let's forget this. Divide the class into 10 groups, tak payah. Okay, so you're given a plastic bag containing 60 pieces of coins or of whatever lah. Okay, ini bukan eksperimen ah, tak payah prepare report. Okay, I will tell you what to do ah. Now, what you do is, after you have this plastic bag, right? Okay, so you shake the coins inside the plastic bag, then you throw everything on top of the table. Okay, crank like that lah. Okay, then after that, you remove all the coins, okay, coins that is displaying the H. Okay, yang menunjukkan H or if you're using coin, yang menunjukkan whichever side is the kepala lah, okay, whichever side is the head okay, you remove all the coins and then you record the number of dice left. Okay, then you throw again, okay, and you, sorry, so this one, sorry, okay, this one, so very easy, right? Throw the plastic bag, not throw the plastic bag lah, throw everything onto a table lah. And that's why you cannot use paper, because if you do paper, then all the paper will fly away. Use something a little bit more, like keras lah, like Manila card lah. Okay, so you put it on the table, and then those with the H you throw away. Tinggal yang ekor sajalah, yang the tails. Okay, then you record the number of dice left. So before, okay, the number of throws, 0 means this will be 60 lah, obviously kan, semua 60. Okay, so after the first throw, berapa yang tinggal? After the second throw, berapa yang tinggal? And you do this for, and you repeat this for 20 times. Okay, repeat step 3 for 20 times. 20 kali kamu repeat. Okay, you repeat. Okay, and then after that, what you do is you fill in the table, okay, which I will show you in a little while. Okay, once you fill in the table is something like this, except that I will show you in a little while how it's different now. Okay, and then after that, what you do is you plot the graph of the number of dice left against the number of throws according to your reading. Okay, according to your reading. So what I want you to see, and what I want you to upload into the Padlet, you upload this into the Padlet, is you draw the graph, and then you determine the number of throws when the dice left is 30, when the number of coins or Manila card lah. Okay, left becomes 30, 15, and 7.5. It's so weird, 7.5. No need lah, 30 and 15 only. Okay, the average time interval. Okay, time interval. Okay, you know what? Let's not do this first. Okay, we skip this first lah. I just want you to plot the graph and tell me the number of throws, okay, when the coins become 30 and 15. Okay, so you write the number of throws when coin becomes 15, okay, equals to how many throws? Number of throws when coin becomes 30 equals to how many throws? Sorry, 30 first bahkan, sebab daripada 60 kan, then become 15. Okay, so just write down the number of throws. Okay, so what you do is you plot the graph. Okay, plot the graph or whatever. Then you write your answer somewhere at the side over here. Okay, number of throws when the one becomes this, number of throws when the number of coins becomes 15. Okay, just write your two answers here and then upload that one page only, okay, just do everything in one page, one graph paper, okay, and then upload it into the Padlet that I will show you a little bit later. Okay, so it's a very simple activity, and I don't think it will take you all 10 days to do this. Oh, sorry, how many days? Friday, Saturday, Sunday, Monday. 4 days. Because Tuesday is next class, right? Okay. Yeah, so even for 5ST, Tuesday is the next class. So it will take you a couple of days to do this. I bet you it will not even take you 1 hour lah. Okay, it will take you much less the amount of time that it takes for you to make a simple decision. Okay, to complete this lah. So 60 coins or 60 pieces of Manila card like this. Make sure you label head and tail. You put it in a plastic bag and you shake the plastic bag, or if you want to put it in a box. Yeah, box is a little bit more stable. So if you put it in a box, Okay, then you shake, 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 shake. And after you shake, you don't have to put it on the table, just open the box lah. Kan, open the box and you see inside. Okay, you see inside. Oh, sorry. Yeah, you see inside the box. Sorry, my box is being covered by my green screen. Okay, so you just see inside the box and then you take out all the H lor, then left all the T. You close the box again, you shake, 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 shake. You open. Of course, when you shake a little bit more vigorously lah, okay. Then you open, then you count. Okay, take away all the H, count how many T is left. Then you record it. Okay, so where do I want you to record this in? And this is how I know that you are doing your work lah. Okay, let me show you where the place to record this. I will send this link to you, all of you, after this class. Okay, so this link is to this Google Sheet. So the Google Sheet is here. So this is called Decay Curve 5SA. There are 24 of you here, so I presume that the other 3 will probably watch this much later. So in this decay sheet, in this decay curve sheet, so the number of throws is already here. Okay, and then you see that there's S1 all the way until S27, right? Try to guess what the S stands for. Of course, the S stands for student. Student 1, student 2, student 3, student 4, student 5, and so on and so forth lah. So you choose whichever number you want. You can be student 1, and if you're student 1, let's say student 1 is Damir, so you write Damir lah. Okay, so that I know that student 1 is Damir. And Damir, kau tulis kau punya jawapan semua di sini. Originally it's 60, so everyone must be 60 lah. Okay, I'm going to write 60 first lah. Okay, so originally memang semua akan bermula dengan 60. Okay, then after the first time, okay, maybe you get 57. Second time, lepas kau ni kan, maybe you get only 43. Okay, huruf T, sorry, not number of dice left, number of tails left. Okay, tails atau ekor lah, kalau duit shilling is ekor. Okay, so number of tails left, you record. And you have to do this for 20 times. Okay, so I would like everybody, okay, to fill in your record here so that I know that, oh, okay, that, kamu ada buat kerja lah. Okay, and there are 27 of you, and for those of you who are in 5ST, there are 33 of you. Of course, not all 33 will probably do this lah, but never mind lah, I'm just going to prepare 33. Ini average adalah saya punya bahagian. Okay, so I will determine the average, and then after that, I will plot my own graph. Okay, based on the average. And then on Tuesday, kita akan bandingkan kamu punya average dan saya punya average. So Tuesday's class will be a little bit different. Tuesday 5ST will have a session. Tuesday 5SA also will have another session with me. Okay, so there's no recorded class on Tuesday. So Tuesday is either you come or you miss the class. Okay, there's no recording for Tuesday. So make sure you complete this work by Tuesday and fill in this. Okay, this table over here. Okay, satu orang satu kolom saja. Jangan juga the whole thing Damir yang buat no, please. Okay, but tolong tulis nama kamu di mana kamu letak kamu punya di sana, so that I know whose reading is where. Okay, after you have done the graph and the answer that I asked you to do, okay, upload your graph into the Padlet. Okay, upload the graph into the Padlet so that I can see what your graph looks like. And then on Tuesday, I will give a bit of comments about your graph. Okay, let me remind you that in the textbook, it says a decay curve. Curve as in lengkung. Okay, so kalau saya cakap lengkung bahkan, maksudnya dia punya graph mesti melengkung. Alright, if the instructions are clear, let me tell you that in my experience, the coin works better than the paper. Okay, but I know that not everybody has 60 coins that are the same type of coin available lah. Okay, unless you own a shop where people pay you in coins, or unless you're a parking agent where everybody pay you $1.10. So coins are going to be difficult lah, but coins will give you a better answer. Okay, coins will give you a nicer curve lah. Okay, let me do it. I did it with coins and I did it with the Manila card. The Manila card curve is okay lah. Okay, it's not to say very nice, but it's okay lah, can lah, boleh jadilah. But the coin one yang lebih cantik. Okay, but there are some teachers that I asked, they say the coin yang lebih teruk lah. Okay, so actually the best is the textbook one. Textbook dia cakap dadu bahkan. But where are you going to find 60 dice? But 60, you know. Kalau 6 dice mungkin lah. 60 dice unless your house runs a gambling den, you know, tempat judi-judi, it's very difficult to find 60 dice. Okay, so we improve this a little bit. We use coins. If you don't have coins, go and buy a manila card, which only costs 45 cents one roll. Okay, and cut out 60 pieces. Okay, if you have a shoe box, is better. Okay, macam saya tunjuk tadi ya, kalau kau ada kotak kasut bahkan, dia lagi senang lah. You don't have to pour everything out then tuang semua balik. Okay, but remember bila kamu bermula dengan 60, the next round hanya T yang tinggal sahaja yang kamu kena goncang. Yang sudah kamu kasih keluarkan itu jangan kasih masuk balik. Okay, macam reputan radioaktif, like radioactive decay. Apa yang sudah decay bahkan dia tidak akan kembali itu. Okay, dia decay tu decay lah. Okay, kalau sudah terlepas kapal terbang, terlepaslah tu kapal terbang. Okay, janganlah minta tu kapal terbang kembali. So make sure that the number, kalau one throw tinggal 0 coin, then come on Wilson, I already said this already. Radioactive decay is impossible. Okay, impossible to be totally 0. But I will give you this. Some of you, okay, and I'm quite sure that some of you will not make it to 20. Betul. Okay, because when you're doing with coins, it is a little bit more predictable compared to radioactive decay. Akan ada beberapa orang yang kau tidak akan sampai pun 20. Okay, let's say lah. Okay, let's say okay, I'm going to put Wilson lah, since Wilson asked this question. Let's say Wilson 60, and then satu kali dia humankan terus jadi kosong. Semua adalah kepala. Then stop. Then stop. Then stop. But it's not possible lah kan. Kalau ini berlaku kan, ini betul-betul adalah freak of nature lah. Okay, but I think for a majority of you, maybe after 12, okay, you will find that you will probably hit 0. Okay, yeah, lucky betul lah. Okay, maybe after 12 you hit 0. Okay, if you hit 0, then you stop there. Okay, you don't have to continue sampai 20 lah. Sebab after 20, kalau kosong sudah kan, memang kosong lah itu kan. Okay, but there are some of you that will not hit 0 at all. Kamu akan teruskan sampailah tinggal 1 atau 2. Okay, tetap juga ada ekor yang degil. Okay, tetap juga ada ekor yang degil-degil ini. So, if that happens to you, happens lah. Alright, but again, the concept of radioactive decay is that it is supposed to be spontaneous and unpredictable. Okay, but the weakness with this experiment is actually it is possible to predict lah. Okay, but this is a simulation that is designed to help you to understand how the decay curve works. So next week we will talk about the decay curve. All right, any other questions? Okay, so I will share the link to this Google Sheet, and I will also share the link to the Padlet where you need to upload your graph. Do everything before next Tuesday. All right.